Hello, welcome back to the channel, MPTS Training Solutions. So today I'll be talking about acids, bases, Ka, pKa, and buffers, and of course Henderson-Hasselbalch equation will also come in here. Now, why is this topic important? This topic, of course, is important mainly because most of the drugs that we take are either weak bases or they are weak acids. And of course, according to Brun's dual concept, as of acid and base. Now, I will not define an acid according to Arrhenius, even those other guys, because I'm sure you know the simple definitions of what is an acid and what is a what and what is a base. Now, of course, when an acid loses a proton, it forms a conjugate base of the acid, and when a base substance gains a proton, it forms a conjugate acid of a base, as shown here. This is now the conjugate base of the acid, the conjugate acid of the base. And of course, when water is present in the reaction, water is an amphoteric and can behave both as an acid and a base, and can interfere with the entire reaction. That's why usually if water is present, we get wrong readings, and at least we can get a poor endpoint. Because water can ionize to form hydrocarbon ions and OH ions. If we go to the OH ions. So let us look at the Ka. Of course, Ka we know is the product constant, dissociation constant. Kb is for a base, Ka is for acid, and Kw is for water. And since we are in water, it has referred to water. Of course, this is the Ka based on reduction above, based on this one. Kw, we have this one. However, there is little change in the concentration of water, hence it can be written as this. But pure water at 25 degrees Celsius, the concentration of hydrogen ions and OH ions is 1 times 10 power negative 7 mole per liter. And of course, Kw forms this. Since it's the same, you must multiply them. Now, of course, pH. Let us go to pH and pOH. Of course, pH is defined as negative log of concentration of hydrogen ions. And of course, since we have said that the concentration of water, the concentration of hydrogen ions at 25 degrees Celsius is 1 times 10 power negative 7. Then using the calculator, the pH of water, the pH of water is this, and the pOH is this. When you add them, you get 14. Yes, this one I'm sure you know why. This is the reason why the pH scale runs from 1 to 14. Now, of course, you can calculate this one, the pOH and pH, but for the concentration of hydrogen ions, when it ionizes, it can become times 2 from mole ratios. So you can come up with that one. Now let us go to the Ka of weak acids and weak bases, since all our drugs are either weak bases or weak acids. This is the equation, an example of the equation. And of course, there is little change in the concentration of this one. So Ka equals to this, as shown here. Now, from that, you can calculate this equation. Calculate the pH of 0.5 molar solution of ammonia with Kb of this, all dissolved in water. It's the equation. Of course, this working formula is the equation. And since we don't know the concentration of the ammonium ions which are formed and OH ion, we can let it be Y. And since they are for mole ratios here, mole ratios is 1, 1, so it is the same, Y. I'm sure from math you can calculate this, so you can always pause to calculate in your calculator very well to come up with the right answer. Of course, the pOH is negative log of this, as shown above, and if you are determining the pH to be a minus. Why pOH? Because ammonia is a what? Is a base. So you can't determine its pH directly. We pass from the pOH. Let's subtract from 14 as shown here. So you can always pause, and I'm sure from the equation above you can calculate this. From the question above, you can calculate this. Now, Henderson-Hasselbalch equation. Now, this equation, I'm sure you guys, you have an idea about it. So, because pKa equals negative log of Ka, and you can derive it. However, me I'll go straight to the equation. This is the equation, Henderson-Hasselbalch. However, it can also be written as this: salt over an acid pH equals pKa plus log salt over the acid, or this one. It's very important. You can always pause to. Now, what are the applications of Henderson-Hasselbalch equation? Which are those applications? Of course, it can be used to determine the pH of a solution, the pKa of a solution, and also it can be used to determine the ratio of ionized to unionized as shown in the last equation above. This one. This one. Questions. Calculate the pKa value of weak acid given its dissolution constant is this one, Ka over this. Now, from the equation above, we know that pK equals negative log of Ka. So you're using your math, you can calculate the pKa. Now, let's go to the second question. Aspirin has a pK of this. Calculate the ratio of ionized and unionized drug in the stomach where the pH is 1.2, and the intestine where the pH is this. And based on this calculation, where is aspirin absorbed? So, this is the equation which we shall use here. And by substituting in and using antlog, you can come up with ionized to and ionized, since we don't know their values. So, of course, ionized is 1 will be 5 over 1000 times this. And unionized will be this. Subtract 5 minus this. The remaining one is the unionized ion. So it is 99.5%. So meaning that in the stomach, aspirin is 99% unionized. And this is the reason why aspirin causes the side effects. Because it will have an acid in the stomach. Again, we have the H from the stomach. Now, aspirin is a double-edged sword as an acid and also inhibiting other prostaglandins. I'm sure this one will be learning later on. And of course, in the intestines, the same thing will happen, but it will be ionized, so which means that it can't be absorbed. Now, what happens during drug absorption? So this will be taught in pharmacology. Because when the drug is unionized, it can easily pass the membrane, and when treated the saturation, it becomes ionized, and hence a phenomenon called ion trapping. The drug can't again come back in the stomach. So that's the rationale of Henderson-Hasselbalch equation in pharmacy. Now, also you can calculate percent ionization using these equations, which you have to know. Ensure you know them. You can pause and then get them. Ensure you know how to press your calculator very well for this one. This is above, it's not below it. 10 power, this one. Sure you can press the calculator very well. Buffers, of course, these are solutions which resist changes in pH when an acid or a base is added. These are the examples of buffers. And again, using Henderson-Hasselbalch equation, you can calculate the pH of a buffer. Because if I have pKa, I have the concentration of this one, the concentration of the salt, I can easily calculate it. How do we measure pH? Of course, pH is measured using pH meter. These are, you know them. I'm sure you have them in your laboratories. Or you can use the simple methods, the indicators. These are they just indicate the where is one acid, that is a base. So this has been a short presentation. Thank you very much for listening to me and watching the presentation. I remain Wilson from Environment Learning Solutions. So you can contact us. We shall always reply. Like our videos, tell a friend.